Okay, so in section 7.2 we're talking about similar polygons. So first we will define similar polygons as polygons with all pairs of corresponding angles congruent and all pairs of corresponding sides proportional. So if I just looked at maybe two triangles, because a triangle is a polygon, let's go ahead and just sketch two triangles. They do not have to be the same size. We just have to have all of the corresponding angles congruent. So we'd have those angles congruent, those angles congruent, and these angles congruent. So we have three pairs of corresponding angles congruent. Now the sides have to be proportional. So if I said that this was 3, 4, and 5, to be proportional, that means that I could double the size. So I could do something like 6, 8, 10. And we'll explore that a little bit more later on how to show that for sure. So let's go ahead and talk about scale factor. So the scale factor is just the ratio between corresponding sides in similar figures. So you have to know that the figures are similar, and then it's the ratio between the sides. We call the scale factor K. Just like we say slope, we use M or whatever variables for certain things. So we call scale factor K. So if you looked in the similar triangles above, we know that they're similar because I told you that they were. And then it would be the ratio between corresponding sides. So like 3 to 6 would be an example, or 3 to 6 written like that, or 3 to 6. Okay, so let's go ahead and do some examples. In example number 1, it says to list all pairs of congruent angles. Okay, now before we can list all pairs of congruent angles, we need to know that these triangles are similar. So typically you will be given a similarity statement, which would be something like triangle RPQ is similar to triangle TSU. So notice this is the similarity symbol. That's the symbol for similarity. It's a little bit different than congruent in that it doesn't have the equal part, because they're not all going to be equal pieces, but just the angles are going to be equal and the sides are going to be proportional. So that means similar. Okay? In a similarity statement, it does tell you what lines up. So the R does go with T, angle P does go with angle S, and angle Q does correspond with angle U. Okay, so let's list all pairs of corresponding angles. We can say that angle R is congruent to angle T, angle P congruent to angle S, and angle Q is congruent to angle U. Okay, so now write the ratios of the corresponding sides in a statement of proportionality. Okay, what that's saying is that side RP is going to correspond to side TS. So the ratio between those sides is 10 to 8. And then we are going to have PQ and SU that correspond. And then we're going to have RQ corresponding to TU. Okay, so right now those might not look equal, but it says check that the ratios of the corresponding sides are equal. So what we want to do is reduce. So in the first ratio here, we can reduce by 2, it'll be 5 over 4. In the second one, we can reduce by 3, we get 5 over 4. And in the third one, we can reduce by 4, and we get 5 over 4. And we can see that all three of those ratios are equal. So we know for sure, we have just verified that those triangles are similar. So angles are congruent, sides are proportional. Example number 2, determine whether the polygons are similar. So here we don't know. We have to make sure that the angles are congruent and sides are proportional. Those are the 2 criteria that we have to meet. Okay? So we see that there are 3 sets of angles, corresponding angles that are congruent. So we have angle H congruent to angle K, angle G congruent to angle M, and angle J congruent to angle L, based upon their arcs or the markings on the picture. Okay? So far we're good on this one. Now let's verify that the sides are proportional. Okay, so we would know that GH corresponds with MK, so we have 9 over 12, and then we would have 15 corresponding with the 20, and then we'd have the 12 corresponding with the 16. We need to reduce these to make sure that they are equal. So the first one will reduce by 3, and we'll get 3/4. Here we'll reduce by 5, and we'll get 3/4. And here we'll get reduced by 4 and get 3/4. Because these are all equal, the sides are proportional. So this meets the second set of criteria. So we do have similar triangles, so we can write a similarity statement. A similarity statement is like this. Triangle GHJ is similar to triangle MKL. Kind of like a congruence statement, but we're using the similarity symbol instead of congruence. Then it says, write the scale factor of figure B to figure A. Okay? Now, that is just the ratio between the sides. So you can pick any of the corresponding sides to use because they're all going to be equal. And if we pick a side in figure B, make sure you're doing it in the order that they ask. Figure B, I'm just going to pick the 12. That corresponds with 9. And if we reduce that, we get 4 over 3. That is your scale factor. And remember, we call that K. You could have gotten that from here, but this was figure A to B, so it was a little bit different. We had to flip that, okay? Because when we verified, we did A to B instead of B to A. Example number 3, it says use similar polygons. So we know that they're similar, and we want to find the value of x. Those are x is one of the sides, and when we're talking about sides, we know sides are proportional. So let's use this side that we want to find the length of, x. That corresponds to the 9. And then we can pick any other corresponding sides that we know both lengths of. So I'm going to pick 8 and 12. We know that those are proportional. From yesterday's lesson, we know that we solve a proportion by cross multiplying or shoestring. So x times 12 is 12x. 9 times 8, or 8 times 9, is 72. If we solve that, we want to divide, and we get x equals 6. So the length of RT would be 6. Okay, so let's talk about the perimeters. If 2 polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So, example 4, a triangular piece of art and its frame are similar triangles. Find the ratio of the length of the side of the art to the length of the side of the frame. So in here we've got the art and then the frame that goes around it. So if we want the length of the art to the length of the frame, we get 12 to 6. But let's reduce that. We can reduce each by 4, and we get 3 to 4. That's the ratio between those, the art and the frame. This can also be called the scale factor. Find the ratio of the perimeter of the art to the perimeter of its frame. Because of this rule right here, we know that that is going to be the same as the ratio between the sides, 3 to 4. You are now responsible for the checkpoint, and you have 3 checkpoints this evening.